Okay, Professor Smoot, thanks for making time for this interview. So what's your impression of the city and how do you view the significance of having such a scientist forum in this small city?
I think the city and the climate are wonderful. It's a great opportunity to take advantage of not only the international flavor, but in fact the very good health. And one of the things I'm promoting is anti-aging and longevity, and there are products here that would make it a great sell and get more tourists to come here and take treatments, the spas, the food, those things. So yes, it was a great opportunity to come here. I love it. I can see why they have this science thing, because a lot of the high administrators and government officials love to come here in December, because December is great. Blue skies, nice weather. It's like spring.
Yeah. You were awarded the 2006 Nobel Prize in Physics for groundbreaking research on cosmic microwave background radiation. So could you tell us about the focus of your current research?
Okay. Well, first let me say what the microwave background is. It's the Nora radiation from the beginning of the universe, from the Big Bang. And it tells us what we did with our research. First was to show it really was the radiation that came from the beginning, and then use it to make an image of the embryo universe. And that started a whole series of things. It's still going on. Part of my research is to try and use that radiation and use the polarization of that radiation to see the gravitational radiation effects on the microwave background that allows it to detect what the real processes were doing during the time the universe was expanding. So that's still going on, but it's a longer term program because you have to build satellites. Right now, one of my big programs is working with the James Webb Space Telescope. We have a team of people, and what we've done is we've selected 10 galaxy clusters. That is, these are very beautiful, fairly symmetric clusters of galaxies, few hundred to thousands of galaxies, and then find ones that have bright sources behind them, and they gravitationally lens it. According to Einstein, if you have all three in an exact row, there will be a ring, because the light will be bent around the center object and down, and you'll see a ring on the sky. If you have a cluster of galaxies, it's very close to a ring, but it's probably a little bit elliptical. But you look at that light from around that edge, you can then see what happens as various bodies in the cluster move around, or from a galaxy move around, and you can do synthesis on them. But you can also try and learn something about the nature of dark matter. One of the questions you're going to ask me is, what's the great new discovery going to be? Understanding what the nature of dark matter is better. We know there's dark matter out there. The question is, what is it? Because we know it's not ordinary kind of stuff, like in this room or like in the sun or whatever. It's something very different, interacts differently. But gravitationally, it makes a big effect. One of the places where we're looking for a breakthrough is to learn the properties from that, from studying these very fine gravitational lenses and studying that, and seeing also when the first galaxies formed, because there are very many candidates still, not as many as there used to be, but they're still seeing the gravity waves from the early universe. That's something we would like to be able to do. There are several different things you can think about. That's the thing about major scientific discoveries. They try to come out of a blue in a certain sense. If they're really major, you're exposing something no one has seen before.
The theme for this year's forum is empowering high-quality development with technology. So in your view, how can fundamental scientific research and technological innovation can drive a national and global development?
So the answer to that is much clearer. In the early days, especially when I first got the prize, but even before that, I would sometimes have to go and testify in front of Congress or places to say why you should fund science and so on. We have been doing studies for years, and we know that when you look at what the increase in GDP or increase in the amount of goods and services available, that in the old days, it mostly came from bringing more people, like taking Chinese out of the villages and bringing them to cities where they could use better tools and their productivity went up, or getting more mining. Right? You mine a volcano, you get a bunch of new wonderful products. Those are inputs that provide increase in the economy, but new ways of doing things with the same stuff, sort of stuff that you invented out of the old stuff. That now we know is about 80% of the growth and the GDP from year to year. My prediction is that in 20 years from now, it'll be 90% because we're going to have many more capabilities. We're going to be able to make many more things. And because many of our products have become digitized. Now, when you digitize, the amount of raw material you need to make new products and do new things is very reduced in cost. And you can reproduce it much more. So the digitization allows a lot of extra things to happen. And so when you combine digitization with more computer power and so forth, it's going to drive the economy a lot more. I was looking at all the new technologies that are coming up now. And so I had a slide that I didn't show, which showed like what happened when they invented trains, and it made a boost to the economy. And that was about a 3-4% per year over a few year period. And then it got sort of stabilized and we're growing at a different level. And then the one that was very big, the biggest one up until now, was when electricity, mass production of electricity came and sort of more modern cars. There were 3 big things that came at once. And that caused about a 5% rise in the economy for a year. But when the computers came, it was a few percent. It's like 4 or 5%. When the internet came, it's like 4 or 5%. But now we have at least 6 technologies. It's going to cause the economy to grow much faster. That's why I'm saying the amount that comes from technology is going to become even greater than 80%. What does science have to do with that? Where do those new technologies come from? You make scientific discoveries, you figure it out. I went to Cambridge for the 100th anniversary of the discovery of the electron. In those days, the economy model, which was a hand-calculated model, had 1 box in it for electricity. Now, 60% of the world GDP comes from electronics and electricity and so forth. Almost everything you work with has some electronics in it. Now we're going to have digitized, most of the electronics is digitized now. Even when you call on a phone, it's not an analog phone like in the old days. It's digitized and then turned back into analog signal for you. So we can expect tremendous more growth of the economy, provided the people can adjust to the new technologies coming in.
And speaking of new technologies, artificial intelligence is one of the prominent topics for this year. So how do you view AI contributing to fields like cosmology, maybe, and energy or biopharmaceuticals? And how can we ensure the ethical and responsible development of such technologies?
So the best is if we could have a world agreement and a world development of the AI, and then we're more likely to get a balanced AI. If you just let companies make AIs, some companies are good, some companies are bad. One of the things that I've seen with developing technology like self-driving cars, the very good companies, their self-driving systems are very safe, don't make so many mistakes, stop before some foolish person gets in front of them, or the great Scania trucks. They have these huge trucks for mining. They don't let humans drive it because it's too much money to be at risk. But they stop and they protect the people. I think it depends on the quality of the company that's doing it, unless the world itself puts out some standards and does some checking and variation. There's too many countries making too much. They have to agree and help encourage it. But AI is one of the 6 things I have on my list that are going to revolutionize our life. I believe you're going to be able to have a device for 10,000 yuan that's smarter than all humans, knows everything that humans knows plus some more, and it talks to you, it's in communication with you in some form all the time from the time you're young. And that will be their teacher, their nanny, making the decisions because the world is going to be changing so fast. You have to have an avatar that handles what goes on in the world. And I'm saying we have these 16 discoveries instead of 3, which caused a 5%. We're going to have 20% change in GDP per year. There's going to be so many products and goods, humans can't keep up. They need an AI that learns who they are and what they like, and then turns around and interfaces and arranges those things. I am enthusiastic for well-developed AI, but the AI is coming. So the question is, how do we adapt the world to that so that we end up with a good world, not a world where the rich people get better and the poor people get even worse, it's a problem, right?
Maybe, yeah, we need to have more cooperation. Yeah.
Now, I mean, the only way it's going to work is cooperation, because if you look at knowledge workers in China, more than 90% already use AI. And if you look at the United States, it's nearly 80%. It's not a question, should we let AI in or not? If there's going to be AI, the question is, when is it going to be general AI? When is there going to be very smart AI? And when there's going to be super smart AI, right? And it's all going to happen. So we have to prepare the world in a good way for that. And then why do you have colleges? You know, here's this university professor who's saying that. But what job would I have in a world where you have in your pocket or your, you know, in your brain, something smarter than everybody?
Yeah. So this event will also focus on the mission of scientists. What are the critical responsibilities for scientists today, and especially in addressing common challenges like climate change or public health?
Yeah, so that is a very good issue, especially with AI, because it's harder now for scientists to keep control of the quality of science. But the real issue of scientists is to actually get towards the real world facts, right? There have been people who say it's all relative and this happens. But the fact is, I think that there's an external world, an external reality, and it doesn't matter what you think, that reality still exists, and it's well ordered, and it's well behaved, and competent observers who don't have bias will see the same things, maybe describe it differently, but they'll see the same thing. And it's often true in physics and other parts of science. You can actually describe the same event with different mathematics and different models, but you get the same predictions and the same answers. That's a way of knowing there's sort of an external reality. It's very important for scientists to stay focused on getting things right, and get the correct description of the world. And then there is a responsibility of scientists, which is what they're doing this for. I mean, sometimes it's because they want the credit for making discoveries and so on. But really, you're doing science and publishing it so that the world can advance. You're funded now, because it's been so successful, we're funded by most countries. And now when there's a crisis, whether it's a pandemic or climate change, which is going to be very serious, or some other kind of things, some other kind of strange things, the scientists should apply some of their knowledge and technology to try and make that better. And so one example that I have is, we know that climate change is going to be bad. We know that China is passing Europe as the number 2 total emitter of, now the US is still ahead, but within a decade China is going to be. It's because even though China is a leader in clean energy and in electric transportation, cleaner transportation, it still produces more emission because it's demanding more power and more whatever it is. And the consequences that is, the more greenhouse gases you put in, particularly CO2, the more the temperature of the world goes up, and the more you get flooding and so on. If you keep putting more in, it's going to cause problems. Now, China is a big, rich country. It can afford, it's going to have to eventually displace 100 million people to new places. Shanghai eventually has to move. And so does most of the Greater Bay Area around Guangzhou, and probably Tianjin. There'll be oceanfront property near Beijing. That's going to happen, right? But China can handle that. But there are many countries that can't handle that. I think it's a burden and a certain responsibility of China, the US, and so on. There's a bunch of countries, and China's share is going to be like 1 billion people are going to have really bad lives or die because of the extra greenhouse gases. The US, similar kind of numbers, although China will get up above it. It is a responsibility of all humans to try and take care of other humans, but it's a responsibility of scientists to give answers. And I look at the conversion towards zero carbon emission, and we've got about 10% of the technologies we need to make the conversion to zero emission. There's another 40 to 45% that we have but haven't been developed, but can be done, and science engineers should be having that. And then there's another nearly 50%, not quite, a little less than 50, that needs to be developed. We don't have all this stuff, because there's certain things we use. Concrete is a terrible emitter, right? Just like transportation, driving around. China is doing great. It's got a big electric car. We did a little count. 1/3 of the cars here are green. I mean, that's huge. But there's still more cars. There are more cars that aren't green cars. It's a challenge, and we're going to go through difficult times. Scientists should be working in that area for two reasons. It's very good for humanity, but second of all, it's a huge growth industry. Converting to clean energy is going to take about 20, 25 years, and it's going to be 5% of the GDP for those years in order to be doing that conversion. And we can't do it faster than that because we got to mine lots of minerals, lots of aluminum, lots of steel, lots of stuff. There's a lot more stuff. So it's good for business. It's good for the economy. We just have to try and do it. So scientists have a responsibility to keep going on. We're really young in the clean energy business. We've had these steam engines and things, say Carnot's cycle machines, for hundreds of years, over 100 and something years, right? Solar photovoltaics, they really have only come to be a third of the energy in China, which is great, better than any, most, not everybody, but better than most of the big countries. But it was still early phase. We have new technology developed, better materials, coatings, all that kind of stuff. That needs science, that needs then companies and so forth to do it. It's a great opportunity, actually. We just have to embrace it and start doing it.